I mean, he can't wait for Christmas. And for him, it takes forever to get to Christmas, or his birthday. It takes forever. And I started thinking about it, I'm like, my God, Christmas was like yesterday in my mind. His birthday was yesterday. His birthday was on October 17th, which is over a month ago now, but it felt like it was just a minute ago. And it makes perfect sense that it should feel like that to me. I'm an old man, right? He's 6 going on 7. So for him to pick up a year of life, when you're 6 years old, picking up a year of life, that's 1/6 of your life. That's like 17% of your life. That's a long freaking time, right? 17% of my life would be almost 6 years, not 1. It would be 6 times faster in the same time period. So, you know, think of it as, no, nothing like that. That's depressing. Think of it like I just said, because that's not depressing. All right, so think when you're a very small child, you haven't burned a whole lot of your life yet. So the next year is a sizable chunk of that which you have burned. Me, I burned, according to the CDC, half of my life. That was what to look at yesterday. You can expect to live to about 82. I'm like, shit, I'm halfway done. Yeah. It's depressing. See, I just thought I wouldn't do that. I just did it. I'm sorry. Anyway, statistics, fun statistics.
Think of it as all the things you're still to do.
I'm totally thinking of it that way, Sandra. I know. I'm totally thinking of it that way. Absolutely. Absolutely. Best half, second half's the best half. But yeah, anyway, the whole relative nature of time and that kind of thing, it's wild.
Yeah, but looking at statistics, you can say, well, I'm going to live a lot longer, I'm an outlier.
Well, and of course, that's one of the concessions. They say I have a 0.22% chance of dying in the coming year. I say me, what I mean is 41-year-old American males. Not adjusted for location, not adjusted for quality of life, nutrition, race, gender, or not gender, yes, but not race. None of those other things. Like you said earlier, heart disease, or you said diabetes actually strikes other ethnic groups different. It's totally a wash. I'm digging deeper to try to find a better number than just 0.22 for all American males. I want to get 41-year-old white American males that moved after 30 years on the East Coast to the West Coast. I'd love to get that number, to get that level of precision. I don't think it's going to happen though. So, anyway. I didn't come here to tell you that today. I apologize. So grab your machines. Let's show you how to use this. This will get you every area you'll ever need for these problems for the remainder of our time here, which is just a week, which is sad. Tear. Just a week. And you can take this thing next. If you guys take 244, you can take it to 244 as well. All right. That's why I gave you guys so many programs. So fire up and press the PRGM button, which is program. Okay, go down to normal. I had to use 8 letters. They don't give you any more than 8 letters, so I had to call it something that would cue you in. So it's standard, normal. Okay, sorry. Grab it, press enter, press enter again. The first thing it asks you is, do you want to do forwards or backwards problems? Now, these are terms I've made up. And the reason I've made them up probably won't be entirely clear until next class together. It'll make a lot more sense there, what the difference between a forward and a backwards problem is. Right now, the only kinds of problems we're going to be doing are called forwards problems. And when we get to backwards, we'll talk about those and why they're called backwards. So let's grab forwards for right now. Let's do some betweens, because it's asking where is the area. And so far, we've been doing between problems, like between -1 and 1, between -2 and 2. Let's just stick with that for a little bit. So between, what's the left bound of the region you want to find the area between? Let's do -1 to 1 again, just because let's see it up on the machine. -1, enter, +1, enter. And what it's going to do is it's going to draw you the curve, it's going to shade you the area, and then it's going to tell you how much area it is down here. So it does all the drawing for you, and it saves you, it draws you a nice bell curve. My bell curves are always too skinny. Like they're always too tall in the middle and too cut in here. This is a much better bell curve shape. Because it's actually drawing using the equation that I'm purposely hiding from you guys. Purposely. Cool?
Cool.
If you want to do more, just keep pressing enter. Enter again. More probabilities? I think so. Forward? Yes. Let's do a between. Again, why not? Between, how about -2 and 2? Now you know what the answer is approximately going to be, right? What's it going to be? Excellent. Here it comes. It ends up being, there it is, about 95%. Closer to 95.5. There you go. And you can do any betweens. What's cool about the program is you're not limited to just -2 and 2. You can do -2 and -1.9 if you needed to. You can go between any two values. They don't have to be symmetric. They don't have to be symmetric at all. Remember when I asked earlier, what's between -2 and -1? That one little tail area, and we had to go, okay, it's 95 minus 68 divided by 2. Totally fine to do that, but you can also just tell it, go between -2 and -1. And it will actually just shade right that little bit and come back with, that's what we said it was about, right? 13.5%? Comes up to 13.5%. Now, it only shows you, and this is a limitation of the TI, it only shows you from -3.5 to about +3.5. That doesn't mean you can't put in numbers that are off the screen. It'll still calculate them for you. Now, you don't often have to do that. For example, yesterday I said pick some numbers, and somebody said, let's go between -5 or -5 and -4. And you can totally do that. Now, it doesn't mean 0. There actually is area down there. But it's so little that it's rounding to 0. Where is -5 and -4? -1, -2, -3, -4, -5. These tails right here are asymptotic. That means they're getting real close to that horizontal axis, but never touching. Which means there's not a whole lot of area out there. There's still area. There's just not a whole lot of area out there. What does all the area under the curve add up to? You know the answer to this. What do all probabilities have to add up to? 1!
1.
So if you shade the entire curve, it would be 100%. This is a little counterintuitive to people. Because how long would it take you to shade the entire curve? Forever. Because it's infinite. And one of the things that blows calculus students' minds offhand is how can something that would take forever to color to be exactly 1? Why wouldn't the area be infinite too, correct? Does you see the problem with that? Like, if it takes you forever to color it in, how can it have a finite area? If it's an infinite area, how can it be a finite area? That's a contradiction in terms, isn't it? Mm-hmm. So I think I have a good way of explaining why. I think. I'm going to run this by you and see if it makes sense. Is this about 1 yard off the ground?
Probably, yeah.
Probably a little too big. We'll call that a yard. That's 1 yard, correct? 1 yard. In order for me to drop this marker to have it hit the ground, it first has to travel half a yard. Fair? Then, in the distance remaining, it has to travel half of that, which would be 1/4 of a yard. Then it's got to travel half of that, which would be 1/8 of a yard. Then it's got to travel half of that, which would be 1/16 of a yard, and then 1/32 of a yard, and then 1/64 of a yard, and then 1/28 of a yard. And you can see how I'll never be done doing that, right? 1/28, 2/56, 5/12, 1024th. Kendra's like, please stop the fractions. Good for you, sister. But you see how that's an infinite series that just keeps cutting in half and cutting in half, and you're adding them all together. So what you end up getting, I'm going to put this here for just a second. You end up getting half plus 1/4 plus 1/8 plus 1/16 plus, and that goes on forever, doesn't it? But at the end of the day, when I drop the marker from a yard, what does it do? It's 100% or 1 yard. Now that, wrap your mind around that. You can add an infinite series of fractions together to get one single number. And a huge chunk of calculus examines just these kinds of convergent series. That's actually Math 253. You get a lot of calculus today in 243, I apologize. So rest easy. There's good mathematics behind this curve summing to 100%. In much the same way that the marker keeps falling half. These pinch down in predictable ways. Fair? Believable? Maybe not entirely believable, but please trust me, the mathematics is sound. I promise. I would not teach you that if it wasn't. It blew my mind the first time I saw that. And the best part was, it was right around Thanksgiving when my first calc professor explained the half to me. And he had this cute little English accent. Suppose you have a turkey, and it's over there. And it was just this adorable little analogy of going halfway to the turkey, and then halfway, and then halfway. It's a little British dance he did. It was quite cute. So anyway, you can put in anything you want, and I didn't limit the program to just betweens. If you go back to the more probs forward, left and right allows you to shade all the way into one of the tails if you want to. So suppose, let's shade to the left, just for grins. Let's shade to the left. If you shade to the left, that means there's going to be a right bound beyond which you stop shade. You don't shade anymore. So pick one of the numbers. Where should we stop shading? From the left all the way up to 1. Love it. 1. Shoo. Now it's keeping track of everything infinitely down here. And when you shade up to the 1, you have shaded about 84% of the curve. Pretty rad, huh?
Mm-hmm.
Hey, here's a question. What's right here? Without using your TI. Now, of course, you can if you want to. Say that again?
Minus 0.5.
Yes! Because isn't from 0 down to infinity half the curve? So that minus 0.5 is going to be 0.3413. Oh, 0.34. That's just about half of what? Which would be negative 1 to 1, wouldn't it? Oh, it's all coming together now. Make sense? It's all coming together. Fair? So that's shading left. You can also shade right. You can also shade right, do the exact same thing if you want. And again, you can pick, you don't have to pick whole number values. You can pick anything, 0.12. That works. Right there. A little strip. Here's what boggles my mind. That's 45%, right? That little tiny strip right there is 5%. That's a huge chunk for as little as it looks, isn't it?
Yeah, it's taller though than the rest.
Exactly, and it's also the pixels do it a due injustice because the pixels make it look wider or narrower than it actually is. But that little tiny sliver, that's just 0.12, 0.12, very close to average. But that picks up 5%. Kind of wild, kind of wild. Fair? Cool, cool. So forwards problems are ones where I give you z-scores and then you pull areas off the curve. That's what a forwards problem is.
Okay.
If you would, let's explore backwards. You guys got that much quicker than I thought you would. That's very, very good. Thank you. Namaste. Let's grab backwards. Let's see if you can figure out what backwards problems are. It says area shades left or right. This sounds familiar. There's no between for these, and there's an intentional reason I didn't put betweens in. Which way would you like to shade, my friends?
Left.
Left it is. Give me a percentage we should shade. Between 0 and 100%, of course. 73%. Now it says to put it in as a decimal. 0.73. I did that intentionally too. I wanted to make sure that you... So why is it called a backwards problem? Or a backwards operation? Say that again, Rachel. Go, go, go. You got it, you got it. Oh, it usually will never be, only because there are way more non-whole numbers. Although I can finagle it so that it's close to a whole number. This guy down here, I can finagle it so it's close to a whole number. That's good. That's good though. Most of them are irrational, which would not be a whole number. I wasn't thinking about that. Good for you, girl.
You put in an incident to see what the z-score is.
It's backwards from what you put in for a forwards problem. In a forwards problem, you put in a z-score to get out an area. In this one, you put in an area to get out a z-score. You see the difference? That's the only reason I go to forwards and backwards. Mathematically, you know what they call backwards operations? Starts with an I. Inverse. They call them inverse. If you look at the actual function names, they're inv normal and normal CDF and inv normal for inverse. But it seems that over the years I've collected kind of anecdotal data, and students seem like backwards better than inverse. So I went backwards, less mathematical. So backwards means you slap area in, and it tells you at what point of the curve you stop shading to capture that much area. I bet you on your Casio it's going to have something like inv, I'm going to guess, Jay, inv norm or something like that. Something along those lines. Please, Linda, go!
What are we supposed to be deducting from this kind?
Nothing yet. All you're pulling off are those values which have meaning, but not on this curve. Just like the letter E by itself has no meaning. It only has meaning when you read it in a word. Oh, I just read the word street. I know when you put an E next to an E, it has a long E sound, and there's that word street. Oh yeah, that means road. So right now you're learning the grammar, if you will. So by itself, grammar is kind of useless. But when you put it into, I don't mean any offense to any English majors, but when you put it into literature, that's when it becomes something. So we're still in the grammar phase. Is that okay? As soon as we talk about idiots, imbeciles, and morons, we're going to get into why we use it. Okay? I promise. I promise. 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 Good so far? Now you could shade either way. For example, we'll go backwards and we'll shade right, and we'll shade 25% right. So a z-score of 0.67, which is 2/3 of the way up from 0 to 1, will trap 25% of the data. That means here is also 25% of the data, correct? Makes sense? Hopefully that makes sense. which means negative 0.67 will be the other 25%, and then down all the way to the tail. The last 25% is your box plot, if you will, from a couple terms or a couple of weeks ago in bell curve form. Kind of cool. So you can shade either way. I like them because they allow us to get percentiles very easily on a bell curve. This is what we were looking at. I didn't tell you this at the time, but when Max's second checkup, when we analyzed that in class, we were actually looking at the percentiles on this curve. The median is 50th percentile. If 50th percentile is the average weight of a 2-year-old child. And then every percentile off of that was, so Max, for example, what was his head girth? Was it 80%? I think it was. He was in the 80th percentile for head girth. Now, what this will tell me is his Z-score to do that was 0.84. But as Linda just pointed out, that doesn't mean anything. It only means something when, well, how big is his head? Well, it's 0.84. No. That's not a measurement. That's a reference point that you then have to put onto a ruler. And that's what the chart gives you, is the go-between between that number and something meaningful. But you're going to understand how the chart's put together now, the grammar, if you will. Does that make sense? Mm-hmm. Now, okay, you guys ready for meeting? It sounds like you're ready for meeting. You're tired. You ever call anybody an idiot? Or an imbecile? Or a moron? Do you know where those terms come from? You know where those, I don't know why I pulled that up, I did this down. Where do those terms come from? Besides middle school. Where do they come from? Do you know? Where are my psychologists in here? Where are my psychologists? Karen. So any recollection of where these, they don't talk about them any